now we are going to discuss the Kleene's theorem part 2. What it says? It says that the language accepted by any finite automaton is regular. So question is that how we can prove that the language accepted by a finite automaton is regular. So one way is to, you can obtain the regular expression corresponds to the given fa, and we know that the value of the regular expression is actually the regular set, which is the regular language. So in order to show that the language accepted by any finite automaton is regular, actually we need to obtain the equivalent regular expression from the given fa. Once I say equivalent regular expression from the given fa, this means the value of regular expression should denote the same language accepted by your fa. So how we can obtain the regular expression from given fa? So we have to use some procedure. We are going to discuss the procedure for obtaining the regular expression from the given fa. So first step is what? Beacon simplification. So we can follow the step 1 and we have to go for the simplify. So what is simplification? Actually, if in some given fa, if we have the more than, if you are given a fa, and if that fa has more than one start state, or we can say one initial state, the initial state or start state is same. When the fa has more than one initial state, then what we need? We need to obtain unique initial state. We need to obtain which has no incoming edge. So like if you are given the fa, okay, if you have the fa like this, okay, so you may have the number of states. I'm not going to draw the all states. The important thing is that you have two initial states. One is this and another is this. If you have the more than one initial state, then we need to use the step 1 of your algorithm, which says that you have to simplify to make the one unique initial state. Now this is the initial state. So how you can go from this state to this initial? Your machine can start from this place, or you can, if you have the more than one initial state, this means your machine can start from this state or your machine can start from this state. So you can make a transition, and you have to transit from this initial state by using null to this initial state. So from the unique initial state, you can go to other initial state by making the null transition. And see that this is the initial, you have only one initial state and no other edges are entering to this initial state. So that's why it is mentioned that that has no incoming edges. Only this is the initial state, and from this initial state you have outgoing edge only, means exiting edge. There is no edge coming from any state to the initial state. So this is the first step of your algorithm. Second simplification you can do, like if your machine has more than one final state, okay, and in the final state you may have some edges which are entering to the, which are incoming, and some edges you may have the outgoing or exiting edge. So in this case we need to obtain one, you have to simplify to obtain one unique final state and exitable. So what we need in this simplification, we are saying that if you have more than one final state, like if you have more than one final state, say you have the final state this may be the final state. Say q1 is the final state and q2 is also a final state. If you have more than, you may have more than two also. If you have the final state like this, if you have more than one final state, and some edges may be coming to this final state, and some edge may also be entering, incoming in this final state. You may have the situation that the edge may also exit from this. Okay, so you may have the situation, in some final state, from some final state you may go to some other states. This may be, so you may go to some other state, like you may go to like q3. So this is the edge which is leaving from the final state, which is, we say that, exitable state. This is the exit edge, you can say. So what we need to do, we need to obtain the unique final state unexitable. So if you have the situation like this, if you have more than one final state, and some state may be the incoming, some state may be the outgoing or exit edge. So the simplification says that you have to obtain one unique unexitable final state. So now q1, once you go for the simplification, now you have the q1 and q2, these were the final state, and some edges are entering like this to the q1, some edge may be entering to the q2, okay, and from q1 some edges are going to the q3 like this. This is q3. So we need to make one final state, unique final state. Say this is the final state. Say this is the unique final state. So from the final state q1, you have to transit to the unique final state by using null transition. From q2, which was the final state, from this place also you can go to this unique final state by making the null transition, and you see that there is no edge leaving to this final state. So this is the simplification first you have to do. Now we need to build piece by piece the regular expression that defines the language accepted by the finite automaton. So how you can do? So you may have the loops like this. You may have the loops, and say this is the corresponds to the regular expression R1. This may be for the R2, and this may be for the R3. So how you can simplify this? So from how you can make the regular expression response to this kind of situation. So from this you can obtain the things like this. So this is the state q, and instead of writing 3 loops, you just say that this is the situation R1 plus R2 plus R3. This you can simplify. So you can simplify like this. You can obtain from this situation to this. Now okay, you may have the situation that you are in the state P and you have the state Q. Okay, so we don't know what is here. We just considering the 2 states P and Q, and you may have some edges, whatever, and we have the parallel edge like this. You have the parallel edge going in the same direction. Say you have the R1, and from P also you are going to the Q for the regular expression R2. So you have the edges, more than one edge which is parallel, and they are going into the same direction. So how you can obtain the regular expression response to this? We can say that you have the state P and you have the state Q and you have the state Q, and the regular expression is like this: R1 plus R2. So actually your machine goes from here to here for this regular expression, or your machine goes from P to Q for this regular. So this plus this union, this R1 union R2 means you have to go for the union. Okay. Now you may have this situation like this. You may have the situation like this. You are in the state P, you have the state Q, and you have the state R. Okay, whatever is this side and this side, you are not worried. So you have the P, and from P to Q you are going for the regular expression R1. From Q you are going for the regular expression. From Q you are going to the R for the regular expression R2. So how you can, so this is the situation actually. This is the situation of actually you are going to do bypass and elimination. Bypass and elimination operation. What you are doing, if you have the situation like this, how you can bypass the state Q, means how you can eliminate the state Q so that you can obtain the regular expression. So from this you can obtain, say, P, this is the state P, then you have to eliminate the Q, you have to bypass Q. So from P to R you have to go from P. So for going from P to R by bypassing the state Q, what you need to do, you have to concatenate. Say from P you are going to the Q for the regular expression R1, from Q you are going to the state R for the regular expression R2, and this is the case of the concatenation actually. So that's why from once you eliminate the state Q, once you bypass the state Q, then you are having the situation like this: from P to Q you are going for the regular expression R1 R2. You can write R1 R2. This is the concatenation of R1 and R2. You are in some state, say for example you are in the state P, Q and R. You have the situation like this. Okay, and whatever is here. From P to Q you are going for the regular expression R1. From Q to R you are going for the regular expression, say for example from P to Q you are going for the regular expression R1. And if you have the loop here, say this is the loop for the regular expression R2, and from Q you are going to the R for the regular expression R3. So how you can bypass the state Q, how you can eliminate the state Q? So for eliminating the state Q, you can obtain from this, you can have the situation like this now: P, Q, so sorry, we are going to eliminate the state Q. So you have P and R. See, once you are going to eliminate some state, then you have to ensure that the paths should not be disturbed. You have to consider every path going through that state. So see that how you can do this. So you are going from the P, Q, R. You have the three state P, Q, R. You are going from P to R, P to Q for the R1, Q. You have the loop for the regular expression R2. From Q you are going for the state R for the regular expression R3. So if you are going to eliminate the state Q, then you have the situation like this. you are not having now state Q. You have the direct edge from P to R. So if you have the direct edge from P to R, what is the regular expression? So you have the regular expression R1. Then once you are at the Q, you can repeat any number of times R2, or you may not repeat. You just R1 and R3. So you have to write R1, R2, Kleene star. Then you can go for the R3. So see, the once you have eliminated the state Q, then you have the regular expression R1, R2 Kleene star, and R3. This is the situation. Okay. If you have if you have this situation like this, like you are in the state P, okay, you are in the state P and you have the state Q, and from P to Q you are going for the regular expression R1, and then for the Q, if you have the Q, and for the Q you have the regular expression, say for example you have the R2, and P you have the, you are going from here, you are going to the state, say for example R to R1, R2, and say for example R3. Then you are going for the state S for the regular expression R4. Then you are going for the state T, say for example for the regular expression R5. So from this, how you can simplify, how you can eliminate the state Q, how you can eliminate the state Q. So we need to eliminate state. So how you can eliminate? So for the elimination, see that what paths are going from the Q. You have to remove this state Q. Once you are going to remove, then you have to maintain the paths. So from P you are going to the Q for the R1, then from Q you have the loop for the regular expression R2, then you can go to the R, you can go to the S, or you can go to the T. So if you eliminate the state Q, then you will have the resulting simplified expression. Once you are going to remove the state, eliminate the state Q, then you will have the situation like this. You are in the state P, okay, and now you have the three, you are not having the state Q, you have the state R, S, and you have the state T. So from P you are going to the, you have the path to go for the state R. So what is the regular expression corresponds to this? So from P you are going for the R1 to the state Q, then you can have the loop here, and you can, the regular expression is R2, and you can make the Kleene star. So you can go for this loop, or you can just go for the state R, and you are going to do the concatenation. So this is the concatenation actually, R1 concatenation with R2 Kleene star, because you can repeat any number of 0 or more times. So R2 Kleene star, then you have the concatenation with R3. So you are going to the, this is one path. Other is you can go from P to S for the regular expression. This is for the R1, then R2 Kleene star, R2 Kleene star, then you have the R4. Similarly, you can go from P to T for the regular expression. What you have the, from P to Q you are going for the R, R1, then Q you have the loop which is the R2 Kleene star, then you have to go for the T for the case of, for the R5. So This is the situation. So once you eliminate the state q, then you are having the situation like this. So this is the way you can eliminate the state. What actually you are going to do, you are going to eliminate the state one by one, and you are going for obtaining the regular expression. So you have to eliminate the states of the FA one by one till you have only the two states remain. One is the initial state and other one is the initial state and other one is the final state. So you have to eliminate all states one by one in some order. Order is not important here. Once you are eliminating the state, then here order is not important. You can eliminate the state in any order. So, but question is that from first step you have to follow for the simplification. After simplification, actually you are going to obtain the regular expression piece by piece, and for obtaining the regular expression you may need to bypass some state, and you have to eliminate, actually you have to eliminate the states one by one of your given FA, and finally you have to repeat this elimination process till you have the two states left. One is the initial state and other means one is the initial state, means that is the unique initial state, and other is the unique final state you have done during the simplification. So whatever regular expression from initial state to the final state you are having, this is the answer. So let us see some example. If you are having the situation like this, this is the unique initial state, there is no incoming edge, and this is the unique final state, you don't have any exit state here, no edge is going to exit from this final state. Okay. Now you have these are the regular expression corresponds to the transition. Now if you want to eliminate the state q, what we need to eliminate state 2. We are going to eliminate the state 2. So how we can do this? Once you are going to eliminate the state 2, this means you will have, since you are going from 1 to 4, you are going in this FA, or you can say transition graph. In this transition graph, you are going from 1 to 2, then from 2 to 4. That means you have the way to go to the state 4 from 1 to the state 2. So you have to maintain this path. So what you need to do? So you can say this is 1, this is your initial state you have, this is the initial state, and you have the state 1. So you are going to the state 1 for the case of null transition, and you have the state, this is the state 3, and you are going to the state 3 for the null transition. Then you have to eliminate the state 2. So you have the state 4. This is the state 4, and you have the state, this is the state 5 you have, and okay. So what you need to do, and this is the final state you have, this is the final state. Now from 4 you have the transition. In the transition graph you have the transition like this, you have the null transition. Now here is, you need to think, you need to eliminate the state, this state, you are going to eliminate the state 2. So how you can eliminate this state? So see that what are the paths going through the state 2. So one path is that if you are at the state 1 and you are going to the state 2, so for what? AB. Okay, then you have the loop. For A you are going to in the loop, then you have one outgoing edge. So one outgoing edge is, it goes to the state 4. So means you have an edge from 1 to 4. You have an edge in the simplification. If you eliminate the state 2, then you have direct edge from 1 to state 4. And what is the regular expression? You have AB. From 1 to 2, you are going for the AB. Then you have the Kleene star. You can repeat the A. You have the loop. Then for the regular expression BA, you are going to the state 2. So you have the BA. So this is the regular expression. Okay. So this is one path. Now what is next? From state 1, you can go to the 2, and other outgoing edge is what? You are going to the state Q5. So you have 2 outgoing edge from the state 2. So one is it goes to the state 4 and other goes to the state 5. So now from 1 you have to go to directly to the state 5. This is directly. You will have the direct edge because you are going to eliminate the state 2. So what is the regular expression for this? So from 1 you are coming to the 2 for the regular expression AB. Then in the state 2 you have the loop. So you can say A Kleene star. Then from the state 2 you are going to the state 5 for the regular expression B. So you can write just B. So this is the regular expression. So AB, A Kleene star, B. Now you have the direct path from A. Now you can consider from the 3. From the 3 you can go to the state 4. So from 3 you can also go to the state 4. And once you are going to the state 4, then what is the regular expression? You have the, you can say this is the triple B. 3 to 2, you are going for the triple B, then A Kleene star, A Kleene star, and then you have the BA. So you are going to B and A. So this is the regular expression. Now from 3, you can also, this is one outgoing edge, other outgoing edges goes to the 5. So from the state 3, you can also go to the state 5. So what is the regular expression for this? So regular expression is, you are going from the state 3 to the state 5. The regular expression is triple B, then A Kleene star, okay, triple B, then A Kleene star, then you are going for the 5 for the regular expression B. So you will have the B here. This is okay. So you have this situation. So in this way you have eliminated the state 2. So once you have eliminated the state 2, you are going to obtain this situation. So you have to eliminate the state 2, and now the edge goes directly from 1 to 4. You have 1 to 4, then you are also going from 1 to 5. So you are going 1 to 4, then you are also going for the 1 to 5. Then you are going from 3 to 4, from 3 to 4, then you are going from 3 to 5 directly, and rest of the things are as it is. We are not going to change. So this is the way. If you have this kind of situation, you can eliminate the state. Let us see the example 2 now. So during this process of obtaining the regular expression, if we have the situation like this, you are in the state Q1, you have the state Q1, Q2, Q3, Q4, Q5 and Q6. From Q1 you are going to the Q3 for the regular expression R1, and Q3 you have the loop which is for the regular expression R3. From Q3 you can go to the Q4 for the R4. From Q3 you are going to the state Q5 for the regular expression R5. From Q3 you are going to the state Q6 for the regular expression R6. What is target? The target is to bypass and eliminate the state Q3. So we need to bypass state Q3. So we are going to bypass the state Q3. Means once you are going to bypass and eliminate, then you no longer you will have this state will not be there, Q3. So how you equivalent you can obtain from this? How you can do the simplification? How you can obtain so that the regular expression corresponds to this will be the same. So if you need to bypass the state Q3, so how you can bypass? So again you have to see that you are at the state Q1. So you have the state Q1, means you are in the state Q1, and you have the state, you are in the state Q2. You have the state Q2, and we have the something else we are not considering. And now we are going to bypass the state Q3, means we are going to eliminate, and we don't have the Q3 now. You have only the state Q4. The Q4, you have the Q5, you have the Q6. So how we can eliminate the state Q3? Say if you are at the Q1, then you have the regular expression R1 and you are going to the state Q3, and you have the loop. Then you are going to the one outgoing edge is to it goes to the state Q4, means you have the direct edge from Q1 to Q4. What is the regular expression? So what is the regular expression for this? You have the R1, Q1 to Q4, R1, then R3 Kleene star, then you are going for the R4. Okay. Next, from Q1 you can go to the Q3, then you can go to Q5. You have the outgoing edge which goes to the Q5 from the state Q3. So from Q1 you can also have the edge, direct edge to the Q5. Yes. So what is the regular expression? You have the R1, then you have R3 Kleene star, and then you are going to the concave with R5. So you have the direct edge now Q1 to Q5, R1, R3 Kleene star, then R5. Now one outgoing edge is also going to the state Q6. So from Q1 you also have the direct edge. You have the direct edge to the state Q6 for what regular expression? For the R1, R3 Kleene star. So you have the R1, then R3 Kleene star, and then you have to go concave with the R6. So this is the situation. So these are the three outgoing edge only. Now you can consider the state Q2. So from Q2 you are going to the Q3, then from Q3 you can also go to the Q4. So from Q2 you are going to the Q4. So you can say from Q2 you are going to the state Q4, and if you are going to the state Q4 from Q2, then what is the regular expression? You have the R2, then R3 Kleene star, R3 Kleene star, and then R4. You have to concave with R4. Now from Q2 you can also go to the state Q5 because you have the outgoing edge goes to the Q5. So from Q2 you can also go to the state Q5. And what is the regular expression for this? You have the regular expression R2. This is the R2. Then R3 Kleene star, R2, R3 Kleene star, and then you are going to the R5 because you are going to the state Q5. Okay. Now you have the regular expression from Q2. You are also going to the Q3, then Q6. So you have the regular expression response to the direct path from Q2 to Q6. So you have the direct path from Q2 to Q6. And what is the regular expression for this case? R2, then R3 Kleene star, and then you have the R6. So using the process of elimination of the state Q3, you have obtained the resulting transition graph, in this transition graph you don't have the state Q3. So this is the way you can remove the state one by one. You can bypass and eliminate the state one by one. So simply you have to actually, during the elimination, you just see that from where you are coming and where you are going. So you will have the direct edge from the state you are coming and the state you are going. This is the way you can use this kind of philosophy for obtaining the transition graph by eliminating the states. So this is the way actually you can use this process. You can use this kind of a scheme for getting the equivalent regular expression from the given transition graph or from the given FA that accept the same language. So we have some special cases like this. If we have the situation like this, you are in the state Q1, you have the state Q1, Q2, Q3, and from Q2 you are going to the state Q1 for the regular expression R3. You have the edge from Q1 to Q2 and the regular expression is R1. You have the loop at the state Q2 and the regular expression is R2. From Q3 you are going to the state Q2 for the regular expression R4. Now we need to eliminate the state Q2. We need to eliminate. Eliminate the state which is the Q2. We need to eliminate the state Q2. So see how you can do this. So once you are going to eliminate, then the next simplified transition graph, you will not have the state Q2. So you will have now, you are at the state Q1 and now you have the two states only. One is Q1 and other one is the Q3. So Q1 and Q3. And whatever here, we are not worried about this. Whatever is here, we are not worried about this. So from Q1, Q2, what is the target? Our target is to remove the state Q2. So what is the regular expression you are going to obtain? What is the resulting transition graph you are going to obtain whenever you are going to remove this state Q2? Here you see that the sum state from in the Q2, some states are incoming also, some states are outgoing also. So see, if you are at the state Q1, then you are going to the state Q2 for what? For the regular expression R1. Then In the Q2, you have the regular expression R2 and you can go for the loop. Then you have the outgoing edge, which again comes to the state Q1. This means you are having the loop like this. So you are starting from the Q1, you are going to the state Q2, and you have the regular expression R1. Once you are at the Q2, you have the regular expression R2, so you can make the Kleene star of R2. Then from state Q2, you have the outgoing edge which goes to the state Q1. So for the regular expression R3. So this is the loop actually you are obtaining. So at the Q1, you have the loop like this, if you have the situation like this. If you want to eliminate the Q2, then you have to do like this. From Q1, you are going to the Q2. From Q2, you can repeat any number of times. This is the Kleene star of the R2, 0 or more times concate, you can say. From Q3, you have the outgoing edge which goes again to the state comes back to the Q1. So that's why you have the loops like this. So from Q1, you are going to the Q2 and then you are coming back to this place. Now, if you are coming to the state Q3, so if you are coming to the state Q3, you are going from the state Q3, you are going to the Q2, then from Q2, you can have the regular expression, you can be in the loop, and you have the outgoing edge, which is outgoing edge R3. So it means that from Q3, you are going to the state Q1. So you have the direct edge from Q3 to Q1. So what is the regular expression for this? You have the R4, then R2 Kleene star, and then you have the R3. So this is the machine you have obtained. So if you have the situation like this, then you can eliminate the state Q2 and you can obtain like this. The process is same, intuition is same. Once you are going to remove the state Q2, then intuition remains same. What in the intuition? The state Q2 will not be there now, you are going to eliminate. So you have to consider the path from the Q1 here, you are going to the state Q2, then Q2, again coming back to the state Q1. So this is the kind of loop. From Q3, you are going to the Q2, then you are going to the state Q1. So you will have the direct edge from Q3 to Q1. So these are the only situations. From Q1, you can go to the Q2, then coming back to the Q1, you have only one outgoing edge. And from once you are at the Q3, then also you have only one outgoing edges. So this is the situation. So this is the special case. Now we consider the special case 2. Okay. So if you have the transition graph like this, so what we need? We need to eliminate the state Q2. So once you are going to eliminate the state Q2, what is the resulting transition graph you have? So again, you have to use the same process of the elimination. So you have now, once you are going to eliminate the state Q2, now state Q2 will not be there. So you have the, you are having the state, you are the state Q1, and you have the state Q1, and then you have the state Q3. We need to eliminate the state Q2. So you have the Q1, and from the Q1 we have one loop here, which is the R1, regular expression R1, and from Q3 also we have the loop for the regular expression R2. Now if you want to remove the state Q2, you want to eliminate the state Q2, then see what you need to do. One thing is that you have the direct path from Q1 to Q3, so it's okay. So you just draw the path. So you have the direct path from Q1 to Q3. And what is the regular expression? Regular expression is R8. Now you have to remove the state Q2. So what is there? From Q1 you are going to the state Q2, then you have the loop at the Q2, then you have the outgoing edge which goes to the state Q3. Means you have to draw the direct edge from Q1 to Q3. So you have to draw the direct edge from Q1 to Q3. And what is the regular expression? So you are in the state Q1, and for the regular expression R2 you are going to the state Q2, then you have the R4 and you can make the Kleene star for the R4, then you are going to the state Q3 for the regular expression R5. So R5 you have to concat. So from the state Q1, if you are at the state Q1, then regular expression is R2, then state Q2 R4 Kleene star, then the outgoing edge goes from Q2 to Q3, and for the regular expression R5. So you are at the Q3. Any other thing from the Q1? So this is one outgoing edge you have from Q2, you are going to the state Q3. But other outgoing edges, so other edges also from Q2 to Q3. So you have to also consider for this. So if you are at the Q1, so from the Q1 you are going to the state Q2, okay, and from the Q2 you have the regular expression R4, you can make the Kleene star, then instead of going to Q3 you are also coming to the Q1. So Q1 and again you are coming back to the Q1, means this is the kind of loop you have. This is the loop. So what is the regular expression corresponds to this loop? So from Q1 you are going to the state Q2 for the regular expression R2. Okay. Then from the Q2 you have the loop which is for the regular expression R4. So you can make the Kleene star of the R4. Then you are coming back to the state Q1, and for the Q1 you have the regular expression R. So this is the loop. So if you start from the Q1, then you are going to the state Q2, and this is one outgoing edge. If you start from the Q1, you are going to the Q2, then this is other outgoing edge. These are the only two outgoing edge. Okay. Now you can consider for the Q3. So if you are in the Q3, so you are going to the state Q2 for the regular expression R6, then one outgoing edge is also R5. So you go to the state Q2 for the R6, then from the Q2 you have the R4 for loop for the R4, regular expression R4, then one outgoing edge again comes back to the state Q3. So this is also the kind of loop you have. What is this? So you are at the Q3 and you are going to the state Q2 for the regular expression R6. Then you are at the state Q2 and you have the regular expression which is the R4. So you can make the Kleene star. Then you are coming back to the state Q3 for the regular expression R5. So this is the loop you have. So if you are at the state Q3, you are going to the state Q2 for the regular expression R6, and at the Q2 you have the loop, so R4 Kleene star. Then you are coming back to the state Q3 for the R5. So R6, R4 Kleene star, then R5. Other thing is, you can start from the Q3, you are going to the state Q2, then regular you have to loop, and then what other outgoing edges which goes to the state Q1. So you should have the direct path from state Q3 to Q1. So you can see that you are at the state Q3, and you should have the direct path from Q3 to Q1. What is the regular expression? You have the R6, then R4 Kleene star, then you have the R6, then R4 Kleene star, then for the R3 you are going to the state Q1. So you will have the what you have. So you are at the Q3, and from the Q3 you are going to the state Q2 for the R6. From Q2 you have the regular expression R4 and you are having the loop, so R4 Kleene star. Then from Q2 you have the outgoing edge which goes to the Q1 for the regular expression R3. So you have to write here R3. And also you have the direct edge from Q3 to Q1. So you can also mention this is. And what is the regular expression for this? The regular expression for this is R9. This is you have done. And now you can further simplify this. So you can, how you can simplify? You have the state, this is the state Q1, and you have the state Q3. Now from the state Q1 you have the loop. One is for the R1 and other is for the this. So you can combine. So this will become one loop for the regular expression R1 plus R2 R4 Kleene star R3. Okay. And similarly for the case state 3 you have the two loops. So one is for the R2. So you have the R2 plus R6 R4 Kleene star, and then you have the R5. From Q1 to Q3 you have the two parallel edges going in the same direction. So you can say like this. You can combine. So one edge is R8, regular expression is R8. So plus other edge is R2 R2 R4 Kleene star and R5. So you have combined these two parallel edges as they are going in the same direction from Q1 to Q3. So R8 plus R2 R4 Kleene star and R5. Similarly, we have the direct two parallel edges from Q3 to Q1 going in the same direction. So from Q3 to Q1. So this is corresponds to the regular expression R9 plus R6 R4 Kleene star, then you have the regular expression, what is R3. So you have the regular expression. So now you are going to obtain the machine like this. So from this, once you have eliminated the state Q2, you are going to obtain this simplified machine, this simplified transition graph. So this is the way you can simplify. So here actually we have covered the all descriptions of the algorithm which you can use for obtaining the regular expression from the given transition graph. So this is the overall algorithms, and we have seen the several examples, we have seen the several situations where you can remove the, where you are going to eliminate the state, and we have also considered some special cases where you see that how you can eliminate the states which seems to be some complicated. But whatever situations you have, actually the things is remain same, intuition is remain same. You have to think that what are the number of outgoing edges, you have to see that, and for every outgoing edge actually you have to give the path. Okay, so there may be the case that once you have the outgoing edge, and it may come back to the same place, same state. So that is the kind of loop you are going to obtain. So this is the process, this is the algorithm for obtaining the regular expression from the transition graph.